What is thermodynamics? Thermodynamics is the combination of two Greek terms wherein we have these two terms, therm and dynamics. See, what is the meaning of therm? Therm means energy. Therm means energy. And if you talk about thermodynamics, we could see that most of the times it deals with heat and work, right? It revolves around heat and work, even though there are other energies as well, like internal energy, potential energy, kinetic energy. There are so many forms of energy, right, which we deal in thermal. And what do we mean by dynamics? The dynamics could mean strength pertaining to motion, or one could say transformation, right? So what is it? Let's go into energy. See, we have four types of energy here: stored, transit, conservative, and non-conservative. What is the meaning of stored? Stored energy is something which is stored in the system, right? Which is there in the system. We could say that system has this much kinetic energy, system has this much chemical energy, or any energy. So what are these forms that are stored form of energy? Kinetic energy, potential, internal energy, chemical, and nuclear. And this list goes so on and so forth. Next, we have transit form of energy. What is this energy? See, in this energy is not energy at all, but it is the mode of transfer of energy. We have two examples, heat and work. Now, these energies are not there in the system, but they are during the process of transformation of energy. What does it mean? We'll talk about it later on when we'll be discussing heat and work in separate video. But now we could say that it could be further classified into heat could be transferred by three modes of transfer: by conduction, convection, and radiation. And work can be of three types, one could say: shaft work, flow work, and process. Now there are other categorization of energy as well, which is conservative and non-conservative. What does it mean? Conservative is something where energy is conserved in the system, in the body. For example, gravitational energy or magnetic energy is conserved in the system, which means it can neither be created nor be destroyed, and it will remain in the system, right? It cannot go away, and it can be reobtained, one could say. Now next we have non-conservative. Examples of non-conservative: frictional energy, viscous force, right? Viscous energy, one could say, and air resistance. Means whatever energy which is lost in friction, in viscous force, in viscosity, or in air resistance. Whatever form of energy that is lost in these, and this could be any other form where energy cannot be regained, where when energy is once lost, it cannot be obtained, right? So that is a form of non-conservation. So non-conservative energy, we have given the examples, right? Energy lost in friction, viscosity, or air resistance, anything. Now let's come to transformation. Transformation is the transformation of energy. That means one energy is converted into work, right? Because when we are saying thermodynamics, where therm means energy, and that energy when transformed or converted, that is our thermodynamics. And how do we convert energy? Energy conversion could be possible, like heat is converted into work in heat engine, and work can be converted into work in refrigerator or heat pump. And this energy conversion is not merely conversion of heat and work only, but also of the energy of the various kind. For example, work is converted into electrical energy via generator, right? And transformation could also mean that why the energy is flowing. For example, the heat flows due to temperature difference, right? So that potential gradient, or that change in temperature, that difference in temperature, could also mean transformation.